Hello everyone, welcome back to my channel. In this video, we're going to work on a real project using the Siemens S5T PLC. I've written a program to start and stop an electric motor with a delay. When I press the start button, the PLC waits for the preset delay time and then it sends the command to start the motor. Similarly, when I press the stop button, the PLC waits for a short delay before stopping the motor. Let's take a look at the hardware I've prepared for this project. An S5T PLC, an HMI, and an electric motor. The HMI stands for Human-Machine Interface. Using the HMI, I can send commands to the PLC and monitor important data from it. The delay time is fully adjustable from the HMI, so I can easily change the start and stop delay without modifying the PLC program. I've set the start delay to 5 seconds and the stop delay to 7 seconds. When I press the start button, the PLC waits 5 seconds and then starts the motor. And when I press the stop button, the PLC applies the 7-second delay before stopping the motor. This is a very practical project, and if you stay with me until the end of the video, I'll explain every detail step by step. I'm going to break this project down step by step. First, I'll walk you through the hardware, and then we'll move on to the PLC program. The MPI port on the S5T PLC uses the RS485 communication protocol. If you want to build your own MPI cable, you can use a standard 9-pin male connector. In this connector, pin 3 is data positive. Pin 8 is data negative. These two pins carry the RS485 differential signal. After preparing the connector, connect the data positive and data negative lines from the PLC to the RS485 port of your HMI, following the wiring instructions in the HMI catalog. You'll also need to provide the HMI with a 24-volt DC power supply to power it up. The PLC doesn't require any wired input buttons for this project, because all commands come directly from the HMI. But if I want, I can still add 2 physical push buttons so the motor can be controlled both from the HMI and manually. I'm using one of the PLC's digital outputs to control the motor. The output drives a relay, and the relay then energizes the contactor. When the PLC activates its output, the relay switches on, the contactor pulls in, and the motor starts running. I'm using a relay because the PLC outputs are transistor-based and can only handle 24-volt DC loads. However, the contactor requires 230-volt AC, so a relay is necessary between the PLC and the contactor to safely switch the higher voltage. Let's move on to programming the PLC. I'm using TIA Portal for this project, and I'll guide you step by step through the process. In this video, the first step in TIA Portal is to create a new project and configure the hardware. I've already completed these steps, so now we can go straight to the programming section. In the first network, I set up the start-stop logic for the motor. I used an SR flip-flop and assigned 2 memory bits for its inputs, M1.0 for start and M1.1 for reset. I also defined M1.2 as the SR flip-flop's operand address. Since the control commands come from the HMI rather than physical push buttons, I replaced the hardware input with an internal memory bit. This memory bit is mapped to an HMI tag, so the operator can send commands directly to the PLC. In the second step, I set up 2 timers, an on-delay timer and an off delay timer. The on delay timer works like this. When its input is active, the timer starts counting, and after the preset time elapses, its output is activated. The off delay timer works slightly differently. When its input is active, the output turns on immediately. When the input is deactivated, the timer starts counting, and once the time elapses, the output is turned off. I use these two timers in sequence. First, the on delay timer, then the off delay timer, before the final output. When the SR flip-flop is activated, the on delay timer begins counting, and after the delay, its output turns on. The off delay timer follows, ensuring the output remains active as needed. When I press the stop button, the SR flip-flop is deactivated. This stops the on delay timer and deactivates the off delay timer input. However, the off delay timer's output continues running until its preset time ends, and only then does the motor finally stop. Now, there's a small challenge when setting timer values from the HMI. The HMI sends an integer value, but the PLC timers require the S5T time format. To solve this, we need to convert the integer from the HMI into the S5T format before assigning it to the timers. Let's move on and see how we solve this problem step by step. In the temporary variables, I created 4 variables, 2 set as time and 2 as S5T. You could use a data block, but I prefer using temporary variables here. I named them with the prefix T for clarity. For example, T0 is a time variable, and T1 is an S5T format. In the HMI, I set the delay time using mWord20. In the PLC program, I multiply mWord20 by 1000 to convert the value from seconds to milliseconds. Next, I use the move instruction to store this result in T0, which is defined with the time data type. Then, I use the time convert function from the extended instructions to convert T0 from the time format into the S5T format. I store the result in T1, which is defined as S5T. Finally, I assign T1 to the timer input, allowing the timer to use the value from the HMI correctly. This process is repeated for the off delay timer, so both timers can work with HMI defined times. And now, a quick note about the HMI. In this project, I'm using a Kinco HMI, and the software is Kinco HMIware, which is very easy to work with. In the interface, I simply added 2 push buttons, one for start and one for stop. For the start button, I assigned the address M1.0. And for the stop button, I used M1.1. To set the delay times from the HMI, I added 2 numeric input fields. For the on delay timer, I assigned the address mWord20. And for the off delay timer, I assigned mWord22. That's all we need on the HMI side to send the delay values to the PLC. Alright, that brings us to the end of this tutorial. In this video, we built a complete motor control system using the S7300 PLC, connected the HMI, and created both on delay and off delay functions with fully adjustable timing from the HMI. You also saw how to convert the integer values from the HMI into the correct S5T time format so the timers work properly in the program. If you found the video useful, don't forget to like, subscribe, and share it with others. If you have any questions, feel free to leave them in the comments. I'll be happy to help. Thanks for watching, and I'll see you in the next video.